Hi, so in this video I'm going to talk about something that occurred to me yesterday as I was editing another video from this series. Basically, I was editing uh, the video number 2 in this series where I did the installation of Debian, and it occurred to me that I never explained why I chose to use btrfs subvolumes instead of partitions or LVM's logical volumes. And I thought it would be a good thing to cover here. And so I decided to record this additional video to explain it. And secondly, there's also another thing that I wanted to cover in this same video is if you watched that video number 2 on installation of Debian, after I finished the installation, since I encrypted 2 different partitions on separate hard drives, I had to enter the password every time I boot twice for each partition separately. But then I thought maybe there is a way to just to set it up in such a way that you don't have to enter it twice, and there is. And the reason I thought of that is because when I ordered my laptop, Tuxedo Stellaris 16-inch Generation 5, I ordered it with the encrypted, everything basically. It's encrypted. So, both SSDs are encrypted, and I'm only asked to enter the password once. So I thought that, there must be a way to kind of avoid entering the same password if you use the same password for each of the encrypted partitions. And I googled it and I found the solution to that. So that's what I'm going to cover in this video as well. So sort of additional thoughts on the installation of Debian. So without any further ado, let's so we'll start with the btrfs thing. So I have this this graphic over here. Let me position it first. This is the same graphic that I used in that installation video, just to illustrate what my partition layout looks like. And basically, there's 2 SSDs, and on the first SSD there's an EFI partition and also a boot partition. The boot partition is needed for the encryption. That's what gets set up if you go through that guided partitioning that I showed in the installation video, for guided partitioning for LVM with encryption. So that's why the boot partition is there. Now, and then there's 2 main partitions on each of the SSDs. On the first one and in the second one, that's the only partition. And then I created a logical volume to cover both of those partitions, so that the entire space on both hard drives is basically seen as you could say, as a single partition by the system. Well, it's called the logical volume. That's what LVM can do. And I covered that in my installation video. But then within that logical volume, I have 2 btrfs subvolumes, one for root and one for the home directory. So it's a typical setup to have root and home separate, so that you can, for example, reinstall the system. You can install a new distribution of Linux, for example, on root, and then your home partition will stay, or in this case subvolume, subvolume or partition will stay there, and you won't have to delete all of your user files, and all of your configs will still be there. So you install the new system and then you have everything ready to go. So that's the advantage of having root and home separate. But I could also have done it just I could have also just used this main partition on my SSD1, I could have done something like use the one main partition for root and the other main partition for for home or something like that, or but that would be like pretty ridiculous, because then I would have like almost 4 terabytes for the root partition, and that's like never necessary. So I could have instead just created 2 logical volumes of like appropriately sized logical volumes for root and home. So like then the question arises, well, why not just do that, and why do we need to have btrfs subvolumes? And so the reason I chose to have btrfs subvolumes is because of the functionality that btrfs provides. And I watched a few tutorials on YouTube on btrfs, and I'll link to a couple of those in the description, and you can take a look if you're interested in learning more about btrfs. But the main 2 things that I wanted to mention here when it comes to like my decision as I made it, like why I want btrfs, is one is to have the ability to take snapshots, which I also talked about in the video where I talked about time shift. So like time shift can use btrfs to take snapshots of the system, and this is extremely efficient because those snapshots get taken very quickly. Like in the couple of tutorials that I watched, people said like it's almost instantaneous. I'm not sure what will happen like if you fill up like if, for example, the root subvolume, that if you're taking a snapshot of the root subvolume, I don't know what would happen if you had it like if it was a very large size, and maybe it was the first snapshot, or like the previous snapshot was very different from this new one that had suddenly a lot of data. Maybe that would take longer. I'm not sure about that. But basically, in any case, it is definitely true that btrfs creates snapshots very quickly, and that's amazing because it basically provides almost the same type of functionality that you might see in VirtualBox with these snapshots, where you can roll back the system to any state that you have a snapshot of previously. So if you want to like upgrade the system and you're like hesitant as to will I like the new version, or maybe there is some compatibility problem that I don't know about. So like you can always have a snapshot, and then you can roll back to it very quickly, and you can take snapshot very quickly as well. So that's an amazing feature to have. So that's one of the reasons that I wanted to have btrfs. And the other reason is because the btrfs subvolumes, they don't have a set size restriction to them. So like if you create a logical volume or a partition, you have to, well, it's slightly different with logical volumes, but like if you create a partition and you say you make your like root partition, I don't know, like 50 gigs or something, then you're stuck with that size pretty much, unless you want to like resize partitions. But that's just like, that's complicated, and it might like it's not an easy thing to do, basically. Resizing them, and like in any case there will be this limit, like you kind of will have that limit of 50 gigs, and it's not always clear like how large to make it. Like you don't really know how much space you're going to need in the future, or like if you make it too large, then you'll waste your disk space. Your other partitions will have less space available. So it's just like it's a very complicated decision to make. Like with logical volumes, it's different because I think, and I'm not 100% sure about that, but I'm pretty sure that it's much easier to resize them, and that might be less of a problem with logical volumes. Again, I say might be because I haven't tried that myself. So, but I'm pretty sure that like from what I watched on YouTube, that it's basically much more flexible, but it's still quite different with btrfs subvolumes, because like if we let me see, so maybe I can just like boot up my VM and show you. Yeah, I'll do that. So I made this rollback here, so I just want to make sure that it's actually rolled back to the current state. And okay, I'll boot it up, and I'll show you exactly what I mean by they don't have a fixed size. So I just entered my password twice, and I'm gonna be fixing that shortly. Come on, snap. There we go. Okay, so like I'll just open up a terminal and I'll type the lsblk command. So maybe this command doesn't show what I wanted to show exactly. Or maybe dfh will show us what we need to see. Yeah, okay, so this is better. Forget the lsblk thing, because that shows something slightly different, but this is more relevant. So here's our root subvolume, and here is our home subvolume. You can see that they are the same size, but they're also both the same device. So basically, what will happen as you use the system, like the more data you put like in your root or home, like this size will decrease for both subvolumes, and like, but they will still remain separate. But you don't have to make a decision of like, okay, I'll have to dedicate like this amount of storage to like root and this amount of storage to home. Like, it's very flexible. I really like it. There's also a feature in btrfs that's called quotas, and you can by using that you can like you can limit the size if you want to like, maybe like you want only like 50 gigs on your root, and you can assign like a quota to it, and then it won't grow larger. It won't take more data than that quota allows it to take. But there's also like one caveat to that. I think that feature in btrfs is not quite ready yet, because let me show you that what I mean. There's this page. So yeah, basically on this page you can see that quotas, it says mostly okay. So this feature is not entirely stable yet, and the tutorial that I watched on YouTube, it was advised there that you might not want to use it just yet. But at least that's something that is being worked on, and so basically you could like, at least once that feature becomes stable, you can like limit the size of your subvolumes by assigning quotas to them. But that's actually not something that I'm really interested in. I really like the fact that you can just like have a root and home as two separate subvolumes, but they can take up as much space as needed. That really works for me. So basically this is why I decided to use btrfs, for those two reasons. Because subvolumes are flexible when it comes to their size, they don't have that limitation, and because of the snapshots feature. I talked about it in the video where I talked about time shift. So and showed how snapshots work there as well. So I'll link to that video in the description. So now that we're done talking about btrfs and why I decided to use it instead of partitions and or logical volumes, or yeah, partitions or logical volumes. Now let's go ahead and set up the VM in such a way that I don't have to enter the same encryption password twice on each time I boot up the machine. So let me Google. So let me see. Let's say crypt tab Debian same password. Yeah, and I think this was the yeah, okay, this is the right one. So I found this answer on Stack Exchange, which tells you how to set things up. So I'm just gonna go through these steps. Basically, what you need to do is you need to add this option, key script equals decrypt underscore keyctl. You also need to install the key utils package, or like you need to edit this option in the crypt tab file. Then you need to install this key utils package. Then you need to run this command to update init ramfs, and then I think that's it. Yeah, that's it pretty much. So I'm gonna go ahead and do that. So let's first install that package, I guess. I'll go ahead and type sudo apt install key utils. Okay, that's done. Now let's edit the crypt tab file. I'll type sudo nano etc crypt tab. So here's the crypt tab file, and I'll add here to both of the drives, or to both devices, I guess I should say. The key crypt, I'll just paste it actually. Won't be able to do it on the, or I mean, I would be able to do it on a real machine, but yeah. So I'll just paste that on each line. Oops, missed the comma here. And yeah, so one thing I wanted to just like briefly mention, that like this guide doesn't have this discard option, and so I looked into that. Let me save this file because I'm done editing it. This is basically what you need to do. I just wanted to briefly mention what that discard thing is all about. So if you go to like man crypt tab, manual page on the crypt tab file, and you search for discard, it says that it allows using of discards trim in parentheses requests for device. So I didn't know what it was, so I went on Wikipedia and I searched for like trim. What was the page called? Let me just Google it. SSD trim Wikipedia. Yeah, this is the thing. So, and this explains basically what trimming is. This paragraph specifically kind of explains what it is pretty clearly. It says that trim was introduced soon after SSDs were introduced. Because low-level operation of SSDs differs significantly from hard drives, the typical way in which operating systems handle operations like deletes and formats resulted in an unanticipated progressive performance degradation of write operations on SSDs. Trimming enables the SSD to more efficiently handle garbage collection, which would otherwise slow future write operations to the involved blocks. So basically, it seems that it's a quite important thing for SSDs to have, because there is some performance degradation involved, and it also seems to say that the future write operations might get slower if you don't have trimming enabled. But there's also like a caveat to this, because it has some security risks associated with it. I forgot how to like. Never mind. So it says here that it advises you to assess the specific security risks carefully before enabling this option, and says that, for example, allowing discards on encrypted devices may lead to the leak of information about the ciphertext device, such as file system type, used space, etc., if the discarded blocks can be located easily on the device later. On the Wikipedia page, it also mentions this here, like in this passage, it kind of talks about like what security risks might be involved. But basically, I think I'm going to leave it on because I would like my SSDs to work well and last me a long time. And like, yeah, that's the option I'm going with. So basically, yeah, that's what I wanted to say about the discard option, because over here it doesn't have it. So now, so I installed keyutils, I edited the crypt tab file. Now I need to run this update init ramfs-u. So I wanted to try something. So basically, like if I go like which update init ramfs dash, or like not dash u, but just that, like it doesn't find the program, and the exit code is 1, which means error. That it means that which didn't find update in init ramfs, but actually it is there. It's just located in sbin init ramfs, or update init ramfs. Init ramfs. There it is. But like I wanted to see like maybe if sudo init ramfs would work, because I don't know, maybe root has it on its default path or something. Was just curious about that. Yeah, it did find it. So apparently like root has access to system binaries, this sbin folder, but like normally it's not like available on the path for like a normal user, I guess. But that completed with success. We can see the exit code is 0, and we didn't get any errors. So now if I just like reboot, I should, let me just check if I did everything. Yeah, that should be it. So if I reboot now, I should only get asked once for the password. So it already says here caching passphrase for SDA3_crypt. It said something different before, so it already is a good indication that it worked. But let's go ahead and enter the password. And yeah, now it says using cached passphrase for SDB1 crypt. So great, it worked, and now I don't have to enter the password twice. So this is pretty much, yeah, this is it for this video. That's what I wanted to show you guys. I'm going to go ahead and shut this virtual machine down, and I'll take a snapshot of that so that we have yeah, so that I have it saved in this state. So what did I do? I set up what was it called again? Decrypt keyctl password caching, or I don't know, like decrypt ctl is enough. Okay, so this is it. This is what where I'm gonna end this video. So thanks for watching. I hope you found this video useful, and that it helps you set up your system in a way that you like. And check out some of the other videos in this series. They cover a lot of kind of similar topics that are relevant to setting up Debian from scratch, and like building it up from a minimal install, and like just only installing things that you need, instead of having a bunch of things installed for you and just like having them there but never using them. And this way you can just like only install what you need and choose to install specific things. That's one of the goals of this that I have for this series. So yeah, thanks for watching, and I'll see you in the next one.